students, for your benefit, we are doing some recording. I will send this video to you. Just in the last class, what we have done, we will do a quick recap on Biot-Savart's law. Then we will start doing the applications one by one. Recall the last class about the Biot-Savart's law. Again, I'm writing. So what we are getting, this is the current flowing through a length of the wire. And according to Biot-Savart's law, what I told, the entire length you cannot, okay. So for the entire length, you cannot apply Biot-Savart law. So what you can do, you can cut a DL length, right? And from there, what we are doing, we want to find the magnetic field at intensity due to that length DL of the wire and at the point P, right? And what we have told that if this angle is theta, so according to the Biot-Savart law, we know that the differential magnetic field dB in vector form, what we have done is mu naught by 4 pi and I into dl cross r, right, divided by r cube. This is the vector form, what we have discussed in the class also. And mu naught is the absolute permeability, right? Mu naught is absolute permeability, right? In free space. Just we are doing a quick revision, right? I and this distance is r, right? So in vector form, this is the vector form. In scalar form, what we have done, that dB is actually mu naught by 4 pi. I cross product means dl, dl into r sine theta, right? Divided by r cube. So this will cancel, it will become r square. So finally, we will get mu naught by 4 pi into I dl sine theta by r square. This is the most common form of Biot-Savart law. From there, we will get that dB. And if you integrate, you will find the total magnetic field, right, for this section. And things to be noted that mu naught, the unit of mu naught is nothing but Newton per ampere square. Newton per ampere square, right? You can get, you know that dB is nothing but Newton per ampere meter, and this is ampere, right? And this is length square means meter square. This thing is mean meters, so you will get Newton per ampere square. You can get, you can easily calculate what is the unit of this mu naught from this thing. You will get Newton per ampere square. And mu naught by 4 pi, what is the value? It is 10 to the power minus 7. Please remember this thing. So if the question comes, you can easily put the value and you can get the desired results. Okay. Now, what we are intending, we want to find the magnetic field due to a finite state current carrying wire. This is one application of Biot-Savart law. One second. So what we need to do, this is the statement I'm writing. Magnetic field due to finite straight current carrying wire. Now, how to get the magnetic field into a finite straight current carrying wire? It is not infinite. So please remember. So it is the length is finite. So what we are doing? Let the length is L of t. We are writing the total length. We are letting that the value is LT. T stands for total, right? And according to Biot-Savart law, what we can say that the magnetic field at the point P, you cannot find for the entire length, but for a small length dl, that we have already discussed. But still, we are let's say the current I is flowing. The current I is flowing here, small I, right? So this length of the wire, right? The total length is L of t. The total length is L of t. Now there we are doing 2 points. We are taking 2 points. One is A and another one is B. Minutely follow. So length of this small segment, we are taking this is small L. The length of the small segment we are taking as small L. Now what we are doing, we can cut a small segment that is DL here, right? And if you integrate, it will come the total length of AB, right? A small length D of L we are taking, and we are letting that this point let's say we are taking that this point is P, and from this point we are letting another, just we are joining these 2 points. We are joining these 2 points, right? And from this A, we are taking a straight line, which is actually perpendicular to this plane. From P, it is perpendicular to this length. So the angle will be 90 degrees. In that manner, we are pointing. Let's say this angle is 90 degrees. And this point is P. This is our constant point. So from DL, we need to find the magnetic field at the point P. Recall the Biot-Savart law. Let this distance is small of r, and we are joining these 2 points, and let the angle it is creating between this point B and A, let's say this is phi1, and from this DL, P and the last point, let's say we are taking not from this one, the total A, P and this last point. Let's say this is phi of 2, right? And look at this triangle AB and P. Let's say this angle is theta. Again, I'm repeating. Let's say these 2 points are X and Y. That will be good. Now, look at this triangle. Triangle X, P, and A. Right? The angle it is coming is phi1. Now, consider the triangle, this one, means B, P, and Y. Right? Not B, A, P, and Y. So the angle which is created is phi2. Now we are letting. Another triangle is A, P, and B. The angle it is created is theta. We are letting this angle as theta. Now, this angle is 90 degree. So obviously this angle will be what? 90 degree minus theta. Now please recall the Biot-Savart law. Look here. This angle between this length of segment to the point P, from DL to point P, we are taking as theta, right? But here we are taking 90 degree minus theta. Why it is so? We can take this as theta also. So this angle will be what? 90 degree minus theta. But what we are letting that we are letting this angle to be theta, so that this angle to be 90 degree minus theta. It has some reason. The reason is, please see, if this theta is varying, right? If theta is varying from 0 to phi 1, and this theta is varying from 0 to phi minus phi 2, it will cover the entire length x and y, right? That's why we are letting this angle to be theta, not 90 degree minus theta. Otherwise, what will happen? We will be confused with these angles and all, and it will be very difficult to calculate. For your understanding point and mathematical perspective, we are letting that this angle to be theta, and if this theta is changing from 0, look at this is 0 to phi 1 plus phi 1, it will cover this x, right? Up to this value is 0. It is increasing up to what? Up to phi 1. So this length will be covered again from 0 to minus phi 2, because it is going downward. So if it covers from 0 to minus phi 2, so this length will be covered. So that's why if we want to integrate the thing, right, in terms of theta, so we can get the entire length, right? So that's why we are taking as theta. Now we want to find the magnetic field due to the finite straight line. So according to Biot-Savart law, what we can write, dB is nothing but mu naught by 4 pi, right? IDL by r square, right? Sine of that theta, this angle theta. Now this angle is 90 degree minus theta. So it will be 90 degree minus theta, right? So sine of 90 degree minus theta is cos of theta. So we can write dB equals to mu naught by 4 pi IDL by r square cos of theta. Okay. Now this theta we need to integrate, that we told that I am trying to explain, that this theta we need to integrate up to phi 1 and minus phi 2, right? So that your total, you will get the total magnetic field, right? This theta needs to be integrated from 0 to phi 1 and from 0 to minus phi 2. So you need to change the limit, right? Now what we are doing, look here. We need to integrate to find the total magnetic field. B is nothing but integration dB. In terms of theta, we need to do, right? So the angle of theta, it will change from minus phi 2. You can take plus phi 2 and minus phi 1 also, not an issue. To phi 1 and mu naught by 4 pi IDL by r square, right? It is cos of theta. This we need to determine. Then we will get the total magnetic field. Now look here, mu naught by 4 pi. This is a constant term. I and this r square. I is the current. This is also not changing. This is constant. Now dl is changing, right? dl. We cannot integrate dl with cos of theta. It should be in terms of d theta, right? And here r square is also coming, where the radius is also changing. Please check. This radius is r. If it is changing from theta, this angle is theta, right? That's why the radius is r. Now, if it is increasing, if it is phi 2, so this thing is not r. So this radius is also changing. If it is phi 1 also, this thing is not r. So the radius is also changing. So we need to form r in terms of theta only. Now, how to do? Please, I'm going for this one. If you see this triangle ABP, A, B, and P. You see this triangle A, B, and P. What you can find? What is cos of theta? Cos of theta means base by hypotenuse, right? Base by hypotenuse. So base is nothing but A. Achal, this length we are taking as A. Okay. So this will be A by hypotenuse means A by R, right? This is the hypotenuse, A by R. So cos theta we are getting in terms of A by R. Now R is nothing but A by cos theta. From here we can write nothing but R is equals to A by cos theta, or you can write A sec theta. What you can write? Right. So we got the expression of R in terms of theta. Now another thing is dl. So length will be there, right? This length is L, right? The length of AB. The length of AB is L. Now please check this triangle ABP. What we can get? Triangle ABP I am writing here. From triangle ABP, what we are getting? Right? Let's say tan of theta. Tan of theta is perpendicular by base. Now see here, tan of theta is perpendicular by base, means it will be L divided by A. So it will be L divided by A. This is perpendicular, right? Perpendicular, and this is base. So L divided by A. Therefore, L equals to A tan of theta. Okay. So DL will be what? A sec square theta into d theta, right? Now we got the expression B equals to theta is changing from minus phi 2 to phi 1, right? Mu naught by 4 pi into I A sec square theta, right? Divided by A by cos of theta R square, right? It will be A by cos of theta whole square. And look here, another cos theta term is there, d theta, right? Now look here, A by cos square theta means A sec square theta. So A sec square theta into sec square theta, it will cancel, right? So what we can write, phi theta is changing from minus phi 2 to phi 1, mu naught by 4 pi I into A sec square theta divided by A square. This is again sec square theta into cos of theta d theta, right? This will cancel, this will go off, this will be A, right? Now look here. So B will be what? Mu naught by 4 pi I by A. These are all constant terms, right? It will be changing from minus phi 2 to phi 1, right? Cos of theta into d theta. Please check. Yes, cos of theta into d theta. So it will be mu naught by 4 pi I by A. Cos theta means it will be sin theta. Integration minus phi 2 to phi 1. So finally, you will be getting the expression mu naught by 4 pi I by A. So this is sin phi 1 minus sine of minus phi 2. right? So sine is an odd function. So minus will come here. Minus into minus is plus. So finally, we will be getting mu naught by 4 pi I by A sine of phi 1 plus sine of phi 2. So this will be your final expression. This is your B. You don't need to do this vector notation because we are doing only the scalar terms. So this is the final expression. I think all of you got clear how we are getting. So finally, what I told that if you integrate in terms of theta, you will get the entire length, right? Because it will be changing from 0 to phi 1. So this length will be coming x. And if it is changing up to 0 to minus phi 2, so this length will be covered, right? From the entire length of the magnetic field means you have to integrate up to from minus phi 2 to plus phi 1, right? So, okay. So from there, if you just put and do a trivial geometry, just consider this triangle and all, you will get tan of theta. And since theta is also varying, r is also varying, we need to form an expression from r in terms of theta. So from there, we are getting all the expressions, right? So finally, we will getting uh, the magnetic field where mu naught by 4 pi and I and A, all these terms are constant. Only this phi 1 and phi 2 angles are changing, and we are getting in terms of sinusoidal of phi 1 and sinusoidal of the angle with phi 2. So from there, some problems I will solve now. Very easy problems. One by one, we will do. First example, let's say some exercise. I'm giving exact exercise 1. Let's say the word is there. The length is given. If this type of problems comes in the question, how to solve, right? This is small a. From there, you can easily solve if you understood the previous problem. This I, the current is flowing, the 2 ampere current is flowing, right? And this A is given as 10 meter. The point is up to 10 meter, right? From there, just join all these points over here. Join the points. And this angle is given 45 degree. And this angle is given 30 degree. So simply what you have to do, your capital D is what? Mu naught by 4 pi into I by A. Already we have done this thing, right? Sine phi 1 plus sine phi 2. You put the value phi 1 and phi 2, right? Phi 1 is 45 degree and phi 2 is coming 30 degree. And final value will be Tesla. So if you put mu naught by 4 pi is nothing but 10 to the power minus 7 into I is coming 2 amperes, right? And this is 10 meter, sine 45 degree plus sine 30 degree. So finally, you will get in terms of thing and just do the homework. You will get the answer. Like that, another problem we can do. Just quickly, we will do on Monday. If you have any confusion, you can tell, right? Let's say some square is there. There is a square. I'm giving some problems actually. And the P is at the middle of the square. The point is there at the middle. Okay. Now you need to find the magnetic field for all sides of the square. Right? Let the current is flowing like that, flowing like that, like that. like that. The current is flowing, right? Now, how to solve the problem? Let's say this sides are A, and A, right? We need to find B for all the sides of square. Okay. Now, first step is you join this point. You join these 2 points, right? Now, already you know this angle is 90 degree. Now, some equilateral triangle will form. This is 45 degree. And this angle will be what? This angle will be 90 degree. So, if you draw a straight line, this angle will be 90 degree. This will be 45 degree. And this will be 45 degree, right? 45 plus 45, 90 degree. This is 90, so 180 degree, right? So again, this will be 45 degree, like that. Now, like that, you can join for this one, and all these things will come. Now, my suggestion is you place the right thumb, right? You place the right thumb in the direction of the where. What you can see, the field is actually outward direction. Outward means you put a dot. Just see, you just point the thumb in the direction of the where, and you can see, you curl your hand. So it is coming outward. You can see it is coming outward. Here also, if you just put your thumb here, it is coming outward. Here also you can do the same thing. It is coming outward, and this is also coming outward. So for all the sides, the magnetic field is coming outward, right? So suppose you are doing for this A and B. Let's say this A, B, and C, D. So for A and B, if you do, and we are telling that B1 is the magnetic field for the side AP. So it will be nothing but mu naught by 4 pi, right? The same thing. I by A sine of phi 1 plus sine of phi 2, right? And look at this one. This A is now A by 2, right? Because this side is there. Where we are just considering this triangle, not the entire one. So these two angle will be what? Phi 1 and phi 2. Phi 1 and phi 2 are same. This is nothing but 45 degree. This A will be A by 2 for this side, right? Now, if you put all the values, you will get nothing but mu naught by 4 pi. Don't cancel this mu naught by 4 pi with all these things. It's my suggestion. You will get I by A by 2 and sine 45 degree plus sine 45 degree. So it will be 2 into sine 45 degree, means 1 by root 2, right? So finally, we will be getting something mu naught by 4 pi into 2 root 2 I by A, something like that. And the magnetic field will be outwards. Same thing you repeat. This is for B1. Same thing you repeat for BC, right? Put these things and you will get the same results. You will be getting B1 equals to B2 equals to B3 and equals to B4 because all the magnetic field is coming outward, right? If it is inward also, you cannot do. So outward plus inward, it will be 0. So all are coming outward. So you can just, the total magnetic field will be what? B1 plus B2 plus B3 plus B4, right? And all the values are same. So it will be what? Mu naught by 4 pi into 4, right? So final answer will be 4 into B1, or you can write 4 into mu naught by 4 pi 2 root 2 I by E. And the magnetic field will be outward. So in this way, we can easily prove. And all are outward. On Monday, if you have any confusion, I can give a demonstration. It is not possible now. How it is coming outward. So place the thumb in the uh, wire of this length of the wire and curl it, and we will be getting some outward direction. In this way, you can find, right? Now, another example you can do. Uh, Another example. I will give this as an home task. You just please do the same. If you are unable to solve, anyhow, I will be doing that one, but please practice this one. Let's an equilateral triangle we are taking. At the middle, some point is there, right? And this length is L. This length is L. You need to find the magnetic field B at point P due to all the three wires. Three wires, right? This is 1 and this is 2 and this is 3. Like that, the same thing you will do. One hint I can give, you just draw this line and put it at the middle. So this will be L by 2, right? And this will be L by 2. And just please find out this angle. This I will not tell. Find out this angle, what will be this angle. And finally, we will be getting the total magnetic field. And please find out in which direction the magnetic field is there, outward or inward. This I will not tell. Okay, I can give the direction of the current. Let I assume the direction of the current is in this way, like clockwise direction. Now you can say just place the right thumb in this direction where the current is flowing. Now curl the hand. Now just check it is coming outside or inward or outside, right? You please check. Then you tell. Now another thing I can do. Find the magnetic field if it is a finite straight current carrying wire, right? Find the magnetic field. Find the magnetic field due to finite straight current carrying wire. Can you find out this magnetic field? Now check if finite straight wire means this one. Let the length is L. We are taking the length, let's say this length as L, right? This is a straight wire. The current is flowing in this direction, and we cannot do from this Biot-Savart law, right? For the entire length, what we can say, a small portion dl we are taking like the same thing, and there is a point P, and this distance is small a, right? What we have done, instead of horizontal, this is a straight finite straight current carrying wire we are taking, and we need to find the magnetic field due to that straight current carrying wire, right? We are placing the wire in this direction of the magnetic field, right? Now P is placed in the direction of the straight current carrying wire, right? And previously it was like that only. The P was placed here, right? And it is perpendicular. Now I can easily point out B is nothing but mu naught by 4 pi. Now look here, you can do in this way also. I by A, and what will be the angle then? If it is this angle, some angle, it is creating theta 1 and theta 2, right? These two angles are there. This is theta or phi 1 and this is phi 2. But here there is no angle. So the angles are nothing but 0 degree. So sine of 0 plus again sine of 0 degree. So finally we are getting the value 0. So there will be no magnetic field if it is a finite state current carrying wire. Please remember, if we want to find the magnetic field along the wire, not perpendicular, along the wire, you will not getting any type of magnetic field. Now it is obvious, don't use this formula. You can use from the Biot-Savart's law. From the definition, what we are getting dB, please remember mu naught by 4 pi. Please recall that one. It is I dl sine of theta by r square. You can, this is scalar form. So theta will be 0 degree. Here also it is coming 0, right? Or you can write I cross dl by r cube, right? Mu naught by 4 pi. This thing also I told. This is the vector form. So I cross dl is what? This is nothing but 0. Because cross product, uh, sorry, not I cross dl, dl cross r, and this is I, right? So these two terms will be 0 because dl cross r is nothing but 0 only. So from there we are getting the same thing. There is no magnetic field along the straight current carrying wire. Please remember, right? Now another case I am doing. Find the magnetic field. Find the magnetic field due to infinitely straight current carrying wire. Infinitely straight, right? In previous example, it is a finite length, right? Now we need to deal with some infinite length. In electrostatics also we have done the same thing, right? Please recall. This is infinity, this is minus infinity, right? And some current is flowing I, right? Now there is the point P from where we need to find the magnetic field at that point, and the distance is A. Now there will be some angles, right? There will be some angles. Now what I told, if we are taking this is A and B, right? And this length is, in the previous example, this length is L, right? Now these two angles are what? What it is changing? This is phi 1 and this is phi 2, right? So these two angles are changing. We are integrating in terms of uh, phi 1 and minus phi 2, right? In the previous example, we have already solved. Now look at this length. It is infinite. So infinite means this phi 1 will increase up to what? What will be the value? Literally, this phi 1 will tend to 90 degree, obviously. Because if it tends to 90 degree means what? This thing. So finally, if you increase this length again, this angle will increase. Again, you increase up to, let's say this is not infinite, this point is infinite. From here, look here, the angle will be close to 90 degree. So it will touch 90 degree when the length will be infinite. Like the same thing will happen for phi 2. It will touch 90 degree, then this length will be infinite. So phi 2 will again tend to 90 degree only. Now B is nothing but mu naught by 4 pi. So you will be getting some magnetic field. That is the most important part. If it is tending to the infinite straight current wire, so still you will be getting some magnetic field. It will be sine 90 degree plus sine 90 degree. So it is not 0. So 90 plus 90 means 2. So you will be getting mu naught by 4 pi. Please remember this will be 2I by A. This is the magnetic field we are getting. This is the value. Along the direction AR, you can write some vector notation, but you will be getting some form of magnetic field. If it is a straight line and the point P is in the direction of your length, uh, that length of the wire, the magnetic field will be 0. Now, if it is infinite line and it is placed like that, even if the length is infinite, we are getting some magnetic field, right? These are something we need to remember. Uh, Now, the last part, what we can say, if uh, if it is not total infinite, if it is a semi-infinite wire, what we can say for a semi-infinite wire? Find the B for semi-infinite wire. How to find out what will be the value and all? Semi-infinite means this is infinity and there will be some finite length. Let's say this is A, right? It is not trending to infinity to minus infinity, from infinity to finite point. And this distance is A, and obviously there will be some angle, right? This phi 1 will be tending to what? 90 degree. Phi 1 will tends to 90 degree because the value is infinite here. But phi 2 here is 0 degree because we are not taking this one. So phi 2, there will be no angle. So this is the point P. So this is a special case we can write. A special case where B is nothing but same thing we need to do, same formula and all. So instead of phi 2 is 90 degree, we are getting only this phi 1 plus sine phi 2, right? This is the formula. So phi 2 0 means this will be sine 0. So it will be going 0 and this will be tends to 1. So finally we will be getting mu naught by 4 pi into I by E. So for infinite length, we are getting mu naught by 4 pi twice I by A, and it is quite obvious. In semi-infinite, we will be getting the half of the magnetic field. So it will be mu naught by 4 pi I by A. So this is all about your Biot-Savart law and some applications. So using Biot-Savart law, you can find the magnetic field. There are so many example problems. I am just solving one or two, just giving you a glimpse of the idea. In the next class, we will be doing some Ampere circular law and there will be some applications too. Why will be going for Ampere circular law? Like Gauss law and divergence theorem, all these things we have discussed in electrostatics. We'll be doing the same type of things in electromagnetics in the next class. For this, you please recall and please solve this problem, question number 3. Uh, I will be sending this video recording. You please do it and tell me on Monday. And if you have any queries, right, why it is so, how to find this magnetic field and all, it is very trivial. This formula and all you need to remember also. Finally, we will getting in terms of phi 1 and phi 2. And there are some applications also. We can solve some square for a circle, for a triangle. We can easily find out, but you need to see the direction of the magnetic field, right? If you are confused with this direction, in Monday we will discuss how we are getting this type of things. Very easy. Place the thumb in the direction of the wire and just do a curl of the hand, is twist the hand. In which direction it is twisting your hands and your fingers. So this will be the direction of the magnetic field. Please do it that one. I think all of you have understood, and if you have any queries, you can ask in on Monday. Thank you. I am stop sharing the screen, and I will be giving the recordings also.